Hey everyone, in this video we're going to be taking a look at the problem solving process. Now when I talk about the problem solving process, I am referring specifically to word problems for this particular video. So in this video I want to cover 4 word problems, and at any time throughout the video you could click over here on the left side to go to a particular example. But when doing these problems, these word problems, we want to talk about the 7 steps for problem solving to gain a complete understanding of how we go about solving these problems. And if you're intimidated by word problems prior to this video, I hope after you watch it and you understand the 7 steps, they'll be less intimidating. So let's go ahead and take a look at the 7 steps for problem solving. Okay, now this is just a guide. This is not an official thing, right? It doesn't have to be 7, but it's just a guide to help you gain a complete understanding of the word problem. So let me open up example number 1 here at the same time too, so we can refer to the 7 steps for problem solving. So the first step is you want to understand the word problem. So in a word problem like this here, talking about a helicopter in Gridville, we may want to read this multiple times, read it 2, 3, even 4 times to gain a complete understanding of what's happening in the word problem and what the word problem is asking for. Okay, a lot of times, people aren't sure where they're trying to go, but if we know what the word problem is asking for, that's going to help. That's going to be a guide essentially for us to dictate our moves on how to get to the end result. So step 1, understanding the problem. And step 2, we want to visualize the problem. So this is going to depend on the word problem you're dealing with too. There's a lot of ways you could visualize something, but if you could draw a diagram, if you could draw a graph, or you could draw shapes, or you could draw a picture of the situation, that's further, that's going to help with step number 1 too, in understanding the problem. So if you visualize the problem, if you could draw a picture or a graph or the shapes, it's going to help out immensely. And that's going to help understand as well. So once you write down that information, and once we have that problem visualized, we want to go ahead and assign variables. If there's any missing information, we may want to assign that to a variable. For example, in this word problem here, we didn't get to it yet, but it's asking how far did the helicopter fly. So I may want to say let D be the distance the helicopter flew, right? It's an unknown piece of information, so perhaps we could assign a variable to that. And if there's any other missing pieces of information, we could do the same for that as well. Step 4, once we have those variables assigned, is we could go ahead and try to write some equations using those variables. So in the word problem, if those variables are relatable to each other in some way, you want to try to find that relationship and write an equation. Okay, and once we have that equation, then we will attempt to solve that equation. Oh yeah, and step 4, you may have 1 equation, you may have 2, you may have 3, you may have more than that. Okay, so it really depends on the situation. And then in step number 5, we want to go ahead and solve those equations if at all possible. Okay, and that's going to help us find those missing variables, and hopefully those missing variables will allow us to answer the question. Now a lot of times with step 5, a lot of people do some word problems and they write down equations and the variables and they solve those equations and then they stop. But you need to pay very close attention to what the word problem is asking for, because once you find those answers in for part 5, if you find those missing variables, maybe you have to do something with those missing variables. Okay, and it may be an extra step that maybe you forgot, to do. So you want to go back to the word problem and see what they're actually asking for, and then use your answers to answer the question. And step 7, if at all possible, you want to check your answer. So take a look at your answer. Do you have the appropriate units on there? Does the answer make sense in the context of the problem? Do you have a negative number when it should be positive, or a positive number when it should be negative? Or are you dealing with some outrageous number like a car going 1,000,000 miles per hour, something that doesn't make sense? And so if you understand the problem and you visualized it, then hopefully you'll have some intuition as to maybe what the answer should come out to be. Okay, so these are the 7 steps for problem solving, and throughout the video I'll try to refer back to the 7 steps here. I may have to get rid of it occasionally, but I'll pop it back up if we need it. Okay, so let's take a look at number 1 here. So we have a helicopter in Gridville, and it travels from the police station on Avenue -2, Street 1, to pick up an officer who lives on the corner of Avenue 2 and Street 3. From there, it picks up a second officer at Avenue 1, Street -1, and then returns to the police station. So how far did the helicopter fly? Okay. So I have to admit, this particular word problem is a little bit ambiguous. It assumes that you would know that avenues and streets are going to be perpendicular to each other. Okay, and it calls the town Gridville here. So it's essentially saying, hey, you're on a grid. So, step 1 is understanding the problem. What's happening within this problem? Well, pause this video if you need to and read this multiple times to gain an understanding if you'd like. But as far as understanding the problem goes, we have a helicopter, and it seems to be traveling around the city, picking up officers, and we're assuming it's going in a straight line as well. So there's a few more assumptions that this word problem here is making. It assumes this helicopter flies in a perfectly straight line from one officer to another. Okay. Step 2, we want to visualize the problem. So to visualize this problem, could we draw a graph or a grid? In this case, yeah, we can. I went ahead and drew a grid here. Okay. So this is my city of Gridville. I put the streets as being horizontal. Okay, so any horizontal line here is going to represent a street, and any vertical line here is going to represent an avenue. Now, for this particular problem, it would work perfectly well if you decided to put avenues as your horizontal and your streets as your vertical. It doesn't matter which way you happen to do it. But now we want to have a way of labeling our streets too, because when it says Avenue -2, Street 1, well, this is talking about ordered pairs, just like ordered pairs in the Cartesian plane. So Avenue -2, Street 1, so Street 1, Avenue -2. Okay. So this is going to be my street, and -2 is my avenue address. Okay, so you could imagine this as a city. It's like you're looking down from the helicopter's point of view at a city. Sometimes in the cities we have the streets looking like this, perpendicular to each other. So Street 1, Avenue -2, where would that be? Well, we're going to start Avenue 0, Street 0, so right in the middle. This is our origin. So just like this is the Cartesian plane, Street 1, Avenue -2 means we're going to move right. Street 1, Avenue -2. So these are the streets. Oh, okay, so that means I'm going to move up 1 and left 2. 1, 2. Let me redo something here. I wrote this backwards. let me write -2, comma 1. Okay, like this, -2, comma 1. It honestly wouldn't have made a difference, but in terms of Cartesian planes, typically we put our horizontal movement first. Okay, so that's my avenue, and this is my street. Okay. So you see, even me, when I do this problem, there may be things that I want to switch up and do a little bit differently, just as long as you have an understanding of what's happening. So we're on avenue -2, so that means move left 2 from the origin and up 1. Okay, so this notation is a little nicer than what I just had, right? This is more consistent with the Cartesian plane. Okay, so I'm going to do it like this. Okay, so that's where the police station is, right? So it travels from the police station on avenue -2, street 1. So that's the police station. And then it moves to pick up an officer who lives on the corner of avenue 2 and street 1. Okay, so we have another point. Avenue 2, street 1. Now, could we mark that in our grid? Well, we want to move right 2 from the origin and up 1. Okay. So here we are. Oh, wait, not 1. 3, right? Okay. Boy, all mistakes today, huh? So avenue 2, street 3. That's right 2 and up 3. There we go. Okay, so avenue 2, street 3. Now that's our, so the helicopter is moving from the police station to this first officer here. And now it's going to move from here to pick up that third officer at avenue 1, street -1. So let me be very careful and make sure I actually have the right numbers here. So our next point is avenue 1, street -1. So where's that? Well, avenue 1 is here, and street -1 is here. Okay, so there is my third point. Okay, great. So that's step 2, visualizing the problem. And if you want, you could draw the helicopter's path here. So we're starting here, and it shoots a straight line towards this officer here. And then it moves down. Let me draw another line. It moves down to pick up this other officer here. And then it moves from here, and it flies back to the police station. So we have a nice little triangle here, right, showing the path of this helicopter. And we want to find how far the helicopter flew. Okay, so step 3 now is assign variables. Okay, so assign variables. Well, from here to here, so from the police station to the first officer, we can call D sub 1. And from this first police officer to the second police officer, we could call that a distance of D sub 2. And from the second police officer back to the police station, we could call D sub 3. Okay. So now we have some variables assigned, right? These distances along our helicopter's path. Step 4 is we want to go ahead and write equations. Okay, so could we write an equation that relates to our problem with what we're trying to find? Well, let's see. So perhaps I could write capital D. That's going to be my total distance. Let me write D sub t for total. So this will equal D1 plus D2 plus D3. That sounds good. And now how could we find these D values? So if we knew D1, D2, and we knew D3, then we would be able to fill those in and we could answer the question. Okay, so now the next step for us would be, well, what's D1 and what's D2 and what's D3? Well, since these are just points in the plane, we know a formula to determine the distance between 2 points. So let me move the 7 steps here for now. Let me just get rid of that. So d1 is going to be the square root of, now it's going to be the difference of our x values for these 2 points, so -2 minus 2. So that's the run squared plus, and now what the rise squared, the rise would be 1 minus 3. And that gets squared as well. So that's going to be d1. Okay, and if you forgot the formula, you could go back and look at one of the previous videos. I'll link that in the description below. So if you forgot the distance formula, you could see how we get it there. But the distance formula is you're going to have the run squared plus the rise squared, and then take the square root of that, and that's going to give you the distance. And that just comes from the Pythagorean formula. So let's see what we get for this. So this is going to be the square root. This is going to be -4 squared, which is 16. And this will be -2 squared, which is 4. So we get the square root of 20. Okay, that's d1. Now d2, well, that's the same formula, but we have some different numbers, right? So d2 is from this point here to this point here. So let me label this point. This is the point 2, 3, and this is the point 1, -1. Okay, and let me label this too. This is -2, 1. Okay, so our run would be 2 minus 1, and then we want to square it. So the difference of those x values, 2 and 1, and then the difference of the y values, 3 and -1. So that's 3, and be careful, that's minus a -1. And we're going to square all of that. So now when we do the math there, what do we get? We have 2 minus 1, and then squared, so that's going to be 1. And then 3 minus -1, that's 4 squared, so that's 16. So this is equal to the square root of 17. And lastly, we want to find d3. Okay, so that's from 1, -1 to -2, 1. So we have the difference of the x values. So that's going to be 1 minus a -2. So that's the run squared. And then for the rise, we're going to have -1 minus 1. And that's going to be squared. And so we get 1 minus -2 is 3, and 3 squared is 9. And then -1 minus 1 is -2, and -2 squared is 4. So we get that, which is equal to the square root of 13. Okay. So we have all of our distances here. d1 is square root of 20, d2 is the square root of 17, and d3 is the square root of 13. So now we can go back to our problem here, and we could say, okay, well, the total distance, now that we have our equations, and we sort of solved our equations essentially, we want to go ahead and fill that information in. So this is the square root of 20 plus the square root of 17 plus the square root of 13. Okay, and these are not very nice numbers. If we try to convert these into decimals, we'll be getting an infinite set of decimals. So if you wanted to simplify this, you could do so in a calculator to get some particular answer. But now, whatever this happens to add up to be, we won't be able to combine these, unfortunately, so I'm just going to leave them separate like this. The total distance would be the square root of 20 plus the square root of 17 plus the square root of 13. Okay. And if you get a decimal, you'll see what that is. So, the next step is we want to actually answer the question. So how far did the helicopter fly? And this piece right here will answer that question. This is how far the helicopter flew. Again, you could change this into a decimal if you'd like to combine these. And next up, we want to check our answer. Does the answer we get make sense? Does it look like the helicopter flew 1,000,000 miles or something? No, this looks like a reasonable number. This number is approximately 4.5. This is approximately 4. And this is approximately 3.5. So when you add those together, it seems like a reasonable estimate for a helicopter to fly in this triangle here. Okay, so don't worry if it takes you a couple of tries to do. Even myself going through this, I wrote this backwards. It still would have made sense, but I wanted to be consistent with the Cartesian plane, so I made sure to change it to my avenues first and my streets second. Okay, so moving on, we have, let me get rid of this here, get rid of this. So we have number 2. We have the organizers of the county fair want to fence in a rectangular area for vendors. Okay, so each vendor will set up a booth on the inside of the fence. They need 900 feet of fence to accommodate all the vendors, and they want the rectangle to be twice as long as it is wide. So what should the dimensions of the rectangle be? Okay, let me go back to the 7 steps. Let's refer to the 7 steps for the problem solving again. So step 1 is we want to understand the problem. So again, if you need to pause the video and read this a few times, certainly do so. I encourage that. So essentially we have a county fair and they want to fence in a rectangular area. So this is going to be a key word here. So we have a rectangle. Now each vendor will set up a booth on the inside of the fence. Okay, so everyone's inside of the rectangle. They need 900 feet of fence to accommodate all the vendors. And then they want the rectangle to be twice as long as it is wide. And then what should the dimensions of the rectangle be? Okay, so understanding the problem, we have a shape, we have a rectangle. So we may want to visualize this with a drawing. Okay, this is going to help us understand the problem as well. So we have a rectangle, so let's go ahead and draw the rectangle. So there's going to be my width, there's my length, there's another width, and there's my other length. Okay, so we have 900 feet of fence. And another part for understanding the problem is, it's helpful to write down the data that's given to you in the problem. It's going to help your brain organize it, a little bit differently. If you just read this over and over and over and over again, you may understand it, but if you start writing down the information, it's definitely going to help you understand the problem a little bit deeper. So now we have 900 feet. This, we could label the sides W. Okay, so this is step 3, assigning some variables. And we have L and L. So for length, I like to do a cursive L. Okay, now we want to go ahead and write equations. Well, it tells us we have 900 feet of fence to work with. So that means the perimeter of this rectangle is 900. So now the perimeter of this rectangle is going to be L plus W plus W, or 2L plus 2W, and we know this is equal to 900. Okay. Now, could we solve this? We could solve it in a way, but we won't have an exact number. We won't have what we need. So what else do we have to work with? We know that the rectangle should be twice as long as it is wide. Okay. So what does that mean? When you see twice as long, I think, people would want to jump to, okay, 2 times L. All right, but that's not going to be correct here. What we need is, so they're telling us the length is twice as long as it is wide. So that means the length should be 2 times the width, right? And just use some numbers in there too. You could use some exact numbers. For example, if the width was 5 and we want the length to be twice as long as that, then the length would be 10, right? Or if the width were 20, we would want the length to be 40. So could you turn that into an equation? Well, yeah, this is it right here. L is equal to 2 times W. So if you weren't sure whether this should be W is equal to 2L or L is equal to 2W, you could try some real numbers, and you could say, all right, is that reflected correctly with my formula? If W was 10 and your length was 20, does your formula match that? And if so, then most likely you have it right. So the length is twice the width. That's what we have here. So we know L is equal to 2W. So the idea here is we want an equation with only a single variable because we know how to solve those. We could substitute the L for 2W. Okay, so instead of writing L here, we could write 2W. So this is going to be 2 times 2W, and then we have a plus 2W here, is equal to 900. Okay, now this here is really the main equation. This is the star of the show. Once we get this equation here, then we could solve this for W. Okay, and that's going to be key to answering the question. All right, so let's go ahead. We could solve for W, so let's go ahead and do so. And to do this, we want to simplify the left side, so we get 4W plus 2W is equal to 900. And 4W plus 2W is 6W. And this is equal to 900. Okay, and then lastly, we just want W, so we need to divide both sides by 6. Oops, just 6. So W is equal to 150. And the units on here would be feet, right? Okay. So 150 feet. Now this, you want to be sure to not stop here. This is not actually the answer, right? This is just solving the equation. We know W is 150. And we could check that too. If the sides here were 150, 150, and then 300 and 300, that's a 900-foot perimeter, right? So we know the width is correct. We know that W is equal to 150. Now, we want to go ahead and answer the question. So what should the dimensions of the rectangle be? So when they say dimensions, they want the length and they want the width. Now we know the length is equal to 2W, which is equal to 2 times 150, which is equal to 300, and don't forget the units, feet. And W, we already solved for that. We know it's 150 feet. So the dimensions would be 300 feet for the length and 100 feet for the width. In step 7, you want to check your answer. Do these numbers match everything that was given, and do they make sense? First of all, if we wanted a 900-foot perimeter, these numbers make sense. If we got something like 2,000 feet for the width, well, that's way more than the perimeter, so how could that possibly be, right? So these numbers, of course, should have been smaller than 900. And, Are these numbers positive? Yeah, they're positive. If you got a negative number, something went wrong somewhere. So these answers certainly do make sense in this context. So that's good. So let's move on to the third example. I'll keep the 7 steps up here as long as we have room. Okay, so Rashid subscribes to a cell phone service that charges a flat fee of $12.95 per month plus 2 cents for each minute he uses the phone. He knows that he can afford only $30 per month for his telephone bill. How much time will he be able to spend each month on the phone? So, step 1, we want to understand the problem. We have somebody signing up to a cell phone service, and we see that the cell phone service is charging him a flat fee of $12.95 per month plus 2 cents for each minute. Okay, and there's he has a budget, essentially. He knows he could only afford $30 per month for his telephone bill. So, what that means, you want to make that connection, is there's going to be a restriction to how much he could talk on the phone, right? Because he's being charged 2 cents for each minute. So it's not like he could talk for an unlimited amount of time, right? He only has a finite amount of money here, $30. So, he may want to figure out how much he could talk on the phone, and that's exactly what the question is asking. How much time will he be able to spend each month on the phone? So that's understanding the problem. And step 2, you want to visualize the problem if you can. And this one's a little bit harder to visualize. You may visualize the situation in your head, but there's not much of a picture we could draw for this. It's more of an equation that we could write. For example, one equation that may come to mind is that the total cost is equal to a variable cost plus a fixed cost. Okay, and I know this is, basically step 4 is writing these equations. But if writing equations helps you understand or visualize the problem, then, certainly try that as well. So, how much is this cell phone bill going to cost? Well, let me call that T. So this is assigning variables, essentially, step 3. His total cost will be his variable cost, which is going to be 2 cents. And now, this is important to do here. Do you want to work in dollars or do you want to work in cents? I think most people would prefer to work in dollars, and most of the information here is in fact given to us in dollars, but this here is given to us in cents. So we want to convert it to dollars here, 0.02, and then times how many minutes he's talking on the phone. That's going to be the variable cost. So if he was talking on the phone for 100 minutes, he would be charged $2, right? And that's reasonable, right? If we put just a 2M here, then it looks like if he talks on the phone for 100 minutes, he's being charged $200. So we want to be careful of that mistake. We want to make sure we convert cents into dollars here. I mean, you could convert dollars into cents, but most people would prefer to work in dollars, I believe. So we'll convert cents into dollars as being 0.02. So that's our variable cost. Now what's our fixed cost? Well, no matter what, he's being charged $12.95, right? So we're going to go ahead and add in 12.95. That's already in dollars, so that's fine. Okay, so there's one equation, right? Total cost is 0.02M plus 12.95. So, off to the side, let me just say T. I'm saying that's the total cost per month. And this is on a per month basis. And M is the minutes on the phone. And again, that's per month. Okay, so now, what else do we know? He knows that he can afford only $30 per month. So we know this big T here. We know he could only afford $30. So $30 should equal 0.02 M plus 12.95. Okay. So that's step 4. That's writing the equations. And this one here is the key equation we need to work with. Because when we have this equation here, we could solve for M. And that's going to tell us how many minutes he'll be able to talk on the phone. Okay, this is going to tell us the max number. You know, how many minutes could he talk on the phone so that his bill is $30, which is the amount he could afford. So step 5 is we want to go ahead and solve this equation here. Okay, and well, I don't have a calculator handy, so hopefully nothing goes wrong. But 30. Okay, so again, we want to follow the basic principles of problem solving, which in this case, we want to move all constant numbers to one side and variables to the other. So I'm going to go ahead and subtract 12.95 from the right side and from the left side as well. So 30 minus 12.95 should be 17.05. And this is equal to 0.02 M. Okay, so now we want to go ahead and divide both sides by 0.02 because we're trying to solve for just M here, right? So the 0.02 is a problem, so we need to divide by that. So dividing both sides by 0.02. Now, 0.02, dividing by 0.02, it's actually the same thing as multiplying by 50. So, and if you wanted to do this in your head without referring to a calculator, you could do 5 times this number here, which would give you 85.25. But let me avoid the decimal point for now. So 85.25. And if you multiply by 5 and then you multiply by 10, that's the same thing as multiplying by 50. So normally the decimal point would be right here, but I multiplied it by 10, so the decimal point will be right here. So 852.5. And this is minutes, right? Okay, so you don't need to worry about this mental calculation here. If you have a calculator handy, you could just do 17.05 divided by 0.02, and you should obtain 852.5 minutes. Okay, and that's solving the equation. Now we want to answer the question. So, how much time will he be able to spend on the phone each month? Well, by solving this equation, we in fact did answer the question. You may want to write out in sentence form. You don't have to write it, as long as you have the correct answer with the correct units. I would be fine with that, honestly. But you could go off to the side and say, Rashid could spend 852.5 minutes on the phone each month. So that's answering the question. And then step 7, checking your answer. 852.5. Well, if you go ahead and plug this back into the equation, 0.02 times 852.5 plus 12.95 should give us 30. And I'm just going to trust that it in fact does give us 30. So that's one way you could check your answer, is to plug it back into your original equation and see if you get a valid thing. Also, you just want to make sure, does this number make sense? 852.5. Yeah, that's, more than 10 hours, but that's reasonable for talking on a phone each month, right? 10 hours, that's not too bad. It's a little more than 10 hours, but it's around 10 hours. So as long as you're not getting something, like a million hours or something, you're on the right track somewhere here. And again, you want to avoid negatives for this answer. we can't talk on the phone for a negative amount of time. So if you got a negative for a final answer, you may want to throw it out. Okay, so just check to make sure that it makes some sort of sense, or it's a possible answer for the application. Okay, and let's go ahead and check number 4. Now, this word problem, I really like this one. It's a fun one. So Ruth leaves her house at 9 a.m., driving west along Route 7, which runs right past her house. Okay, and she drives at a steady 40 miles per hour. An hour after she leaves, her husband Jacob realizes that she forgot the slides she will need for the presentation, so he takes off after her, driving at a steady rate of 60 miles per hour. When will Jacob catch Ruth? Okay. Again, feel free to pause the video and read this multiple times and write down any important information. Let's see. Let me underline some things here. We have Ruth leaving her house at 9 a.m. and driving west along Route 7, okay, which runs right past her house. And she drives at a steady 40 miles per hour. Now, an hour after she leaves, let me underline this too. Her husband Jacob realizes that she forgot the slides, and so he starts driving after her, and he's going 60 miles an hour. So Ruth is going 40, and Jacob is going 60. So eventually, he should be able to catch her, right? Because he's gaining 20 miles on her every single hour. So when will Jacob catch Ruth? So that's understanding the problem. What's happening? Now we want to visualize the problem. Well, we have Ruth and Jacob. They live in a house somewhere. Here's the house. Okay. There's the window. There's the roof and a chimney. Okay, so there's their house. There's where they live. Now, Ruth leaves the house at 9 a.m. She takes off west. Oop. Okay, so she's going west. Let me put a W here for west. And she's driving at 40 miles per hour. So let me write that down. Ruth is going 40 miles per hour. And then she forgot the slides, so Jacob takes the slides and he's driving after her. So he leaves the house. He's also driving west, right? Along the same road. But he's going 60 miles per hour. Okay, so he's going faster, so he should catch her at some point. So that's visualizing the problem. You can visualize it how you like. Step 3 is we want to start assigning some variables. Now think about what we're working with here. We have these rates here, and we have some distances and times. So whenever we're dealing with rates, you always want to be thinking, rate is equal to distance over time. Okay, we have this equation here. Now let's see. When Jacob catches Ruth, what can we say about their distances? Okay. We could say that the distance that Jacob traveled is equal to the distance that Ruth traveled. Okay. So we're assuming that Jacob is catching Ruth. And so if he does catch Ruth, that means their distances are the same, right? If someone leaves your house and then you take off after them and you catch them, no matter how long you are running or at what speed, if you caught them, that means that you went the same distance, right? So this here is really the key to be able to figure out this problem here, is knowing that the distance they went is the same. Okay, doesn't matter the time, doesn't matter the rate, but if he caught her, then they went the same distance. Okay, so this equation here, now let's see, what could we do with it? We want to manipulate this in some way because we don't know the distance traveled at all. However, we can use this formula here. Okay, if you solve this formula for d, we see that d is equal to rate times time. Okay, I get this by multiplying by t on both sides, and you obtain this equation. Distance is equal to rate times time. Now, rates is something we do have, right? We do have rates. So instead of writing the distance Jacob traveled, we could say, well, his rate, so Jacob's rate times Jacob's time is equal to Ruth's rate times her time here. Okay, so this is still a distance is equal to a distance, but this is Jacob's distance and this is Ruth's distance. Okay, now we know RJ is 60 miles per hour, right? And we know Ruth's rate is 40 miles per hour. But what about the t's? These are t different values, but could we relate them somehow? Well, Jacob is going 60 miles per hour, so let me fill in a 60 here, times. Now, we refer back to the problem here. Jacob takes off after her. Okay. So an hour after she leaves is when Jacob leaves. So if Ruth was traveling for time t sub r here, then the time Jacob was traveling should be t sub r. So the time Ruth was traveling, but minus 1, right? Because he left 1 hour after. So he's however long Ruth was traveling, Jacob was traveling for 1 hour less. Okay, so 1 hour less than Ruth is this time here. Okay, and now this is equal to Ruth's rate, which is 40, times t sub r. You see, the problem here was we had t sub j and we had t sub r, and we had to relate them to each other somehow. Either we could say t sub j was t sub r minus 1, right? Ruth's time minus 1, or we could say that t sub r would be Jacob's time plus 1. Okay, either way, we wanted to relate these two somehow so that we obtain an equation with a single unknown variable, which in this case is t sub r. If we just left it as t sub j and t sub r, these two are different variables. Okay, they have different names, so we wouldn't be able to solve without making that relationship. Okay, but once we do make that relationship, when we see that their times are off by 1 hour, we could say, okay, well, Jacob's time was Ruth's time, but minus 1. And then over here we just have Ruth's time. So this distance is equal to this distance here. Now we can go ahead and solve that equation. Okay, this was really the most difficult part of this problem, I believe. But once you see it, it's quite a lot of fun to go through. So now, let me get rid of the 7 steps here. I'm going to need some more room to solve that. Okay, so let me just rewrite this. 60 times t sub r minus 1 is equal to 40 t sub r. So let's go ahead and solve this. In this case, we need to simplify the left side first. So we get 60 t sub r minus 60. So what I did was distribute the 60. And this is equal to 40 t sub r. Okay, now we want to move our constants and move our variables if we need to. So let me move my constants to the right. So adding 60 and adding 60. So we get 60 t sub r is equal to 40 t sub r plus 60. Now let me move my variables to the left. So minus 40 t sub r here, so they're gone, and minus 40 t sub r here. So let me come up here, do a little arrow. Okay, so we have 20 t sub r is equal to 60. Now, we just want to solve for this variable, so we need to divide by 20 now on both sides. So we're dividing the whole left side by 20, and we're dividing the whole right side by 20. So we get t sub r is equal to 3. Okay, and since we were dealing with miles per hour here, the time units, since this is time, it's going to come out to be hours. And you could leave units on here the whole way through. If you do everything correctly, it should come out to hours here. Okay, so t sub r is 3 hours. Now, we did so much work, it seems like that would answer the question, but that doesn't answer the question, right? The question is, when will Jacob catch Ruth? Now we want to ask ourselves, what did we just solve for? This is Ruth's traveling time. We know Ruth was traveling for 3 hours. But Jacob, he left an hour after her, so he's only been traveling for 2 hours. Okay. So it's a little ambiguous here, what they're actually asking for. So when will Jacob catch Ruth? You could say, well, he'll catch Ruth in 2 hours. So this is one possibility for a final answer. Another possible answer is that, well, we know Ruth left at 9 a.m. She was traveling for 3 hours. And upon reaching that 3-hour point, the distances between these two people were the same. So we know they caught each other at that point. So what time was it? Well, 12 a.m., right? I mean 12 p.m. 12 p.m. Okay, and another way to see this is Jacob left at 10 a.m. and we know he was traveling for 2 hours, right? So again, we get 12 p.m. for the time at which they met. So this here is really the answer that this type of question is looking for. I know when it says when will Jacob catch Ruth, it looks like these would be appropriate answers as well. You see, actually, this one here, these answers wouldn't be appropriate because when it says, when will Jacob catch Ruth, these are in reference to somebody. You could say 3 hours from when Ruth left or 2 hours from when Jacob left, but essentially, to really answer the question, we would want to say 12 p.m., okay, because we need a common reference point here, and this 9 a.m. is the common reference point. Right, so we do want to say 12 p.m. Although these answers are close. You could say 2 hours from when Jacob left or 3 hours from when Ruth left as well. Okay, so that is problem solving. Right? It takes quite a bit of getting used to, but I mean, if you do have trouble with problem solving, if you could follow the 7 steps, hopefully that gets you a little bit more organized in trying to solve some of these problems. I know they could be overwhelming the first time you read through them. There's so much information being thrown at you. But you need to really take the time to understand the problem, visualize the problem, organize the information by writing down equations, assigning variables, and solving what you can, and keep referring back to the problem to see what they're asking. Okay, and it takes quite a bit of practice. So, if word problems are your weak point, you're going to get better by doing a lot more word problems. If you continue to avoid word problems, there's no way to improve. So even if you struggle through them, that's how you're going to get better at it. So I encourage you to struggle through problems, even if it's a little bit frustrating, but do your best, and hopefully this video helped. So hope you enjoyed this, and I'll see you in the next video.